Well, by Econometrics Chapter. Today we are going to start a discussion using regression analysis with categorical and qualitative explanatory variables. And to help for today, we'll look at testing categorical differences. We'll start off with looking at just two categories. Pretty simple, and then we'll expand that to multiple categories. And then we'll talk about how we can include as well continuous explanatory variables. Multiple regression. Excuse me. If you're trying to do multiple regression on categorical variables, categorical variables, also called binary variables, qualitative. Dummy variables is the most common way. That's probably the easiest way to say. So I've heard that probably more than anything else. But really, these are non-numeric values that are coded to be numeric in nature so that we can do some form of a calculation. And their categorical variables include things like color. It's hard to assign numbers to colors. I mean, I suppose in some software they have numbers that represent a color, but the order of those numbers is a little bit off. Doesn't really make sense. Things like race, gender, disease status, blood type, political party, religion. These are all important categories and they affect aspects of our lives every day. We can still account for them in our econometric models, but we don't treat them like regular numbers. We put them into categories. And I think it might be good to mention something about ANOVA. ANOVA is a great way to look at differences of means when they change. If you have three or more variables, although really you can do two or more. If you want to look a little bit more deeply into the relationship between X and Y variables, a regression can give us a little bit more deeper, and now it can give us a little more stronger understanding than what ANOVA can. And the good news is we're going to be talking about how to do categorical or use dummy variables. And I've got an example with ice cream that we can use. But first of all, really the easiest way to think about this, if you have just two categories, yes or no, you could have it. So if you're comparing something, you could have a base of one thing, yes, and then if it's not the one thing, then it must be the other. And so that's a pretty simple way to think about it. And if you're only looking at one or two different things, it's going to be one or the other, but not both. And so what is the effect of choosing chocolate ice cream over mango ice cream, for example, or whatever? What is the effect of, because for example, you're either male or female. So if you run a regression, you can have the base be male or the base be female. And then when you have it, and when it's a base of something, you put a 0, and then you put the 1 if it's going to be something else. And that's generally how I think about it when I'm running a regression. Let's look at a data set that I have. It's called ice cream. I've got a bunch of things, mango and lilikoi ice cream. And this is a contrived data set, but I think all of this should make sense. Oh, I've got the answer key over here. Pull this up. But first of all, if we want to look at the different flavors that we have, I'm going to look at, let's see, sort. I'll use this formula to look at all of the flavors. It's a unique formula, which is an array formula, so it pulls all the unique values. And flavor comes before mango and lilikoi. That makes it easy. And I want to know, let's do some basic analysis. If you have a data set, it's always good to maybe do some preliminary analysis to scope it out a little bit. We put count. And so to do that, we can do count if. How many of these are going to be lilikoi? 43. And how many are going to be mango? That's going to be 29. Let's look at the number of scoops on average. Then we have some toppings on. Actually, I'm just going to copy this thing right here. Let's get some. I did a paste special values only. And I want to look at some averages on here. And so I'm going to do average if, and I want if I do that, the range, okay. I'm going to look at how many scoops there are. Oh, let's see. Actually, I want to do this. I want to look at how many, if it's mango, or if it's lilikoi, how many scoops the average range is this one right here. That means we have one, I'm going to format that. Oh, well, the 1.58. And if I pull that down, 1.45. So on average, customers who get lilikoi get, well, both of them get about 1.5 on average. I'm going to, the F4 will make that be constant, and I'm going to put, I want the anchor, the column. And so now I can drag that all the way down, drag it all the way over. Oh, the formula didn't work for some. Oh, these are yes, no. Okay. So we have a data set that's yes or no. We can't really turn that in, that yes or no are not numbers. And so I'm going to convert all of these. Let's make it, if it's mochi, yes. Let's give it a 1. Let's give it a 1 value. Okay. And if it's no, let's give it a 0 value. So in this, the base is there is nothing. The alternative is that there is mochi. And that can now copy those formulas all the way over. And it looks like we have, I'm going to turn these into percentages, format to total spent on average. That's going to be currency. So now we see that a little bit more, we had more lilikoi than mango. And this one, they can't have a combination of scoops. I guess the price doesn't really matter. But we just have what they spent. Based off of this, we can run a regression and tell us how much everything costs. And so I'm going to go to data, run a regression, and I want the Y range is going to be total spent. The X range are going to be all of these things right here. We have labels, our output range. Sure. Yeah. And what does that tell us? Well, we have an R squared of 100%. That means there were no errors in what they charged everybody. The intercept is 2. That means every customer is going to pay $2 no matter what. If they get 1 scoop, it's $3. If they get 2 scoop, it's going to be an extra $6. That means 1 scoop is going to cost $5 if you add those two together. 2 scoops is going to cost 2 plus 6, which is $8 for 2 scoops. The mochi topping adds $1.50. Toasted coconut adds $1.25. Lihi mui powder looks like an extra $1. Whipped cream is an extra $1. Macadamia nuts is $1.75. And that tells us how much each of those toppings would cost. So if you want, say for example, if you got a 2 scoop ice cream, so that's going to be that. We have 2 scoop ice cream. You want to do the intercept. Oh, actually here, I'll set this up. Let's do this the easy way. So the intercept is always going to be present. But if you get 2 scoop ice cream and you get the lihi mui topping, whipped cream, and macadamia nuts, how much do you pay? You use the sum product formula. Then you end up paying $11.50 because you got 2 scoops, that's $8. And then you've got what you pay for each of those toppings. And whatever number you put, let's see, maybe, oh, keep the intercept with 1. If you only got 1 scoop, then that's what it would cost. If you end up getting whatever combination of toppings, you can put that in there. 1 scoop with toasted coconut Oh, this is a rounded. Oh, let's see. According to this model, oh, and macadamia nuts. You get the two, just that. Okay, so if you get one scoop with toasted coconut, it's going to be $6.25. All right, so there's our ice cream model. Let's take a look at the PCC that we have. And I've got a bunch of things in here. Let's do our initial analysis that we can. We have, in this, we have a bunch of visitors. We have the country that they're from. And I made a sort, unique, I sorted by alphabetical order, either from Australia, Canada, Japan, Korea, USA. You can use this type of an array formula, or you can click on the little arrow thing if it's filtered, and you can see where all the countries are from. Which village they attended first, what package type they got, what group, let's see, package type are going to be basic, deluxe, VIP. These are all the villages in the PCC. And then what type of a group they might be. If they attended the luau, if they attended the show, how many cultural presentations they attended while at the PCC, how many hours they spent at the PCC, and how much they spent on souvenirs. Here we're trying to figure out expenditures for from going to those. Let's do some percentages first of all, so we can understand, or some averages. And the first one, average if we're looking at how many attended the luau if they're from this country. And let's see what the averages are. And we're looking at what they attended the luau. So 65% attended the luau. I'm going to anchor that. I want to anchor just the column. Now I can copy that formula all the way over, paste special, zero formula. Oh, I didn't like it. So there's something wrong with the formula. Oh, I didn't anchor properly. Okay. $sign for the column. And so now I'm going to bring special formula. So we have, if they're from Australia, 2/3 attended the luau, a little bit more, 3/4 attended the night show. They attended about 3 1/4 cultural presentations on average. They spent just over 6 hours, and they spent $6, $67.50. If we look at it, we can copy the formulas all the way down, and we can get an understanding of how likely they have been, or we can predict in the future how likely something might happen based off of what happened in the past. Okay, so if we want to look at how much did they spend depending on their package type. And so I'm going to take the same formula, just going to copy it. But instead of column B, we want to do package of column D. And I want this to be basic. So it looks like, and let's see, I think I want this one right here. How much they spent on souvenirs. Okay, so the average of first column, the range is column D, what package. The criteria is if it's their basic, the one next to it, and they're going to average the amount of money spent with souvenirs. So basic spent about $44. VIP 102, deluxe $70. Those are the three. So let's look at the same thing by group type. And so I'm going to put that in there. And I want to select the group type. Couple, looks like they spent, if it's a couple, 60, so it looks like the biggest spenders are families. They're buying the most souvenir when they selected the survey participants. And let's go ahead and put these into categorical data. Oh, before we do that, we're looking at multiple groups. So let me go to the slide. When we have multiple groups, you're going to have a base and then how things can be different. So that simple one with just one category, it's yes or no. What happens if we have multiple groupings within a category? For example, when we look at the group type, there's basic, VIP, and deluxe. And so to list that, we say VIP is 0 and deluxe is 0. That gives us our base. You always have to have a base. The basic is going to be when both of those are 0. VIP is going to be 1 for that, and then 0 for deluxe. Deluxe is going to be 0 for VIP, 1 for deluxe. So what we are measuring categorically here is the difference between being basic. You always have, however many category types you have, if that's going to be n, you have n minus 1 number of columns, because your base is going to be all zeros, and you have a 1 or one specific thing somewhere in there. So that's a group type. If we look at, and that's for basic, VIP, deluxe. If we want to see what kind of a category of the group of people that are going in, solo, couple, family, group, same thing. 0 for all is for solo. Couple is 1 for couple, 0 for these other two. Family is 0, 1 for family. The mistake that often gets made is you can't put 1 for a solo column, and then all these, because that doesn't make sense. We're looking at differences from something. You have to have a base of something. Otherwise, you'll get it wrong. And looking from country type, we have 5 different countries, so we've got 4 different columns, which means that if everything's 0, we're looking at Australia. All these should add up to just 1. There should just be one of these columns that has a value in it. And so if we're looking, we run the regression, we're looking at the number, the expenditure for souvenirs, where Canada is. We're only looking at Canada. That's the amount more or less that Canadians spend in Australia. These values could be positive or negative when we run the regression. Okay, so let me go back to where we have. So we need to set up our model. And we'll put, okay, is this person from Canada? Probably the easiest way is if that equals Canada, and then we want a 1, otherwise it's going to be a 0 value. And I anchored. Okay. Oh, and I also want to anchor column, because we have Canada, Japan, Korea. We've got a few countries. And so I'm going to drop this all the way down to the entirety of the data set. And if it's from, just for the moment, I'm going to hide this so I can see it. So you can see where there's Canada, all the Canadians give a 1, 0 otherwise. And then let's see that with all these other. See if I did this right. I'm going to drop this all the way down. Look at some values. Japan, okay, let's hit. Check. It's good to spot check a couple of these. There's Korea, okay, like we hoped it would. And really, I guess what we could do is I can filter this to check it. Okay, min, max, 1, it's good. I mean, that's right. Look at Japan. Oh, min, max, 1. So I can check all these using the filter. Okay, 1s are only on Korea. And then USA, 1s are only on that. And then it should be, let's look at Australia. All these should be 0. We select all of these and come down here, something 0. Okay, we got that set up correctly. Let's look at the Hawaiian village. We'll do the same type of thing. I'm going to copy the formula over. And it is, okay, and move on. And then we can check it. We can spot check it a little bit. And let's see, for example, we pick this, that's London, okay? And you want to do this as far as you want to make sure that it's accurate. Then we have the package type. I'm gonna copy this formula over here. If C, okay, looks good. And then make sure we have the package type. So basic should be all zeros. Good, that's well. Deluxe, one, there. VIP and zero on the other. That looks like it's behaving like I hoped it would. And then is it a couple? We look at this type of a type. Let's see. Okay, that looks good. And then we have cultural presentations. Oh, yeah. And there are souvenirs. How much expenditures on souvenirs? I think, let's see if I remember what this model. I don't think we looked at cultural presentations as part of our analysis. I mean, you could, but let me run this regression. Data analysis regression. Y is going to be spent on souvenirs. Then we're going to use all these dummy variables. And let's put our output. Okay, model looks pretty good. And oh, there's something wrong with Fiji. Min max, okay. I need to. Oh, because it's a. I think I missed it. There we go. Keep going. I'm gonna run this regression again. And I'm not changing it. And I think I might have something else. So let me check my data. Maybe I should check things a little more. Let's see, coupled. Okay, that's the family type. Family student group. 2, 3, 4. We have a couple of family student group and solo. Solo should be all zeros. Okay, looks good. We have couple. Okay. So sometimes it's good just to make sure that your data is set up the way you hoped it would. That's family. And then we have student groups. We're just going to delete this because we have to delete that. So what's this? Now we spend data analysis, regression, A, W to AJ. Okay, and the way that we can interpret this is if they're Canadians, they're spending $5 less than Australians. If they're Japanese, they're spending that much more than Australians and Koreans, $2.35 less. If from the US, they're spending about $6 more. If they go to Fiji first, they don't spend, looks like the one where they spend the most from is if they go to Tonga first. One of these packages, VIP and Deluxe, they spend, VIP spend about $57 more than the solos. So that whatever that is, you're doing good to get the souvenir revenue in it up. Deluxe spend about $25 more. So, and then the basic package is great. I think these are differences from the solo. So we have couples spend less than solos, families spend more. The fact that there's part of a student group, then they spend a little bit less than solos. And that's how we interpret these. Let's look at the Titanic, the last data set that we have. We have passengers, passenger ID, if they survived or not, passenger class, and I put that here, third class. There's their name, what gender, age, if they have siblings or spouse, parents or children, ticket, how much they spent. I think I put some annotation in here. This is from pounds 1912 pound sterling and where they embarked from. So let's set this up. If they survived, and they either did or they didn't, so that's going to be B2. B2, yeah, 0 is no. 0 means they died. If they didn't die, the alternative is that they survived. So we're going to put that in here for our first column. If they were second class, so equals if this equals 2, then 1, otherwise they're not second class. So we're measuring the difference from being first class. So that's going to be there with 2 zeros and they were first class. If that would be good. If they're female, so equals if that equals male, it's going to be 0, give it a 1 otherwise. What the fares that they paid, that equals that, that's what they paid. If they were from France, and so that's if they embarked from France, equals if embarked equals, that's the France one, be the 1, otherwise give it 0. And I'm going to replace this for the Ireland one, because they embarked from Ireland, pick up those of these. Okay, now we can run a regression. And my data analysis, the regression, and we're going to have if they survived. Then the labels we have. You have continuous variables, like we have the fare in here. You treat it just like everything else. It's edited. And we want to add this. Okay. And then we have our output. And what this tells us are things like, for example, if they were second class, they're 10% less likely to survive compared to first class. If they're third class, they're about almost 30% less likely to survive. If they're female, they're 50% more likely to survive. It looks like there's a relationship between the fare that they paid and the probability of being able to survive. If they boarded in France, you're about 8% higher chance of surviving than if you embarked from England. If you're from Ireland, you're almost 7% chance higher probability of surviving than if you embarked from England. Great, that's how we interpret these and run these regressions. Please let me know if you have any questions. Mahalo.